In this video we are going to see integration of tan x. In trigonometry we all know that the formula for tan x, that is tan x is equal to sin x over cosine x. So in the given integration, that is integral tan x dx, we can substitute this sin x over cosine x for tan x, because tan x is equal to sin x over cosine x. So in the given integration we can substitute sin x over cosine x for tan x times dx. Okay, in this integration the denominator is cosine x. So the derivative of this denominator cosine x is negative sin x. Even though we do not have negative sin x in numerator, we have sin x in numerator. So it is very clear the derivative of the part of the given function we have in numerator. So whenever the derivative of a part of the given function is in the integration, we can use the method of substitution. So now I am going to use the method of substitution to get integration of sin x over cosine x. Okay, now as in a new variable, I am going to substitute a new variable for cosine x. So y is equal to cosine x. So why I am substituting a new variable for cosine x? Because I have the derivative of this cosine x in numerator. That is the reason I am substituting a new variable y for cosine x. So now I am going to get the whole integration in the variable y, in the new variable y. Already we have the integration in the variable x. So I am going to change the variable x as y. So for that I need to find the derivative with respect to x on both sides. Here y is equal to cosine x. When I find derivative of y with respect to x, it will be dy over dx is equal to the derivative of cosine x is negative sin x. Further, dy is equal to negative sin x dx. Now we can multiply both sides by negative 1, then I get negative dy is equal to sin x dx. Okay, here in this step, for this part, that is for sin x times dx, we can substitute negative dy over, for cosine x we can substitute y. So we can take this negative out of the integral sign, so negative, and dy over y can be written as 1 over y times dy. Okay, already we know that integral 1 over x times dx is equal to ln x, or integral 1 over z times dz is equal to ln z. So here we integrate 1 over y with respect to y, so we get negative ln y plus integral constant c, because it is an indefinite integral, so we have to add the integral constant c. So we can use the power rule of logarithm, that is we can consider this negative sign as negative 1. We can move this negative 1 as the exponent of this argument y. So in the next step it will be ln y to the power of negative 1 plus c. So ln y to the power of negative 1 can be written as 1 over y plus c. Okay, that is all. The integration process is over. But y is a variable taken by us, the original variable is x. So now we have to replace this new variable y by the stuff what we have in the original variable x. So we already know that y is equal to cosine x. So now we can replace y by cosine x. So our answer should not be given in y, because y is a variable taken by us. So y has to be replaced. So y is equal to cosine x, so y can be replaced by cosine x, positive c. Okay, in trigonometry we know that 1 over cosine x is equal to secant x. So ln of secant x, positive c. Okay, logarithm is never defined for negative values. So this secant x cannot be a negative value. So since the secant x cannot be a negative value, we will be using absolute value for that one. That is ln secant x positive c. So the integration of tan x is ln secant x positive c. I hope this video will be much useful for the students who study calculus. If you like this video, please subscribe our channel. Thank you all.